up, people? Welcome to topic 7, which is all about
linear relations.
So far we've talked about some slope and did some things, and we've seen so far that we have the slope formula, and slope is equal to rise over run. And if we remember, slope is really just represented by a lowercase m, and we get this change in y, which is our rise, over change in x, which is our run, right? Because if we remember last time we talked about the fact that that is a delta, and delta means a change in, and you could think about that as final minus initial, which is something you probably talked about in your grade 10 science classes, which kind of makes sense if we look at what comes next in this formula. We have y2, which is our final y coordinate of our 2 points, minus our initial, our y1, all divided by our x2 minus x1. All right, so if a graph goes up and we read from left to right, we could say that the function is increasing. Heckin' right. And the slope must therefore be positive.
Likewise, if a graph goes down as we read left to right, then we can say the function is decreasing. And then the slope must be the opposite as well, which is negative. Sorry for my bad writing, as always. Okay, so in the next couple examples, 4 to be exact, we're going to look at finding the slope between each pair of points, then stating whether that slope represents an increase or a decrease. So for this process, remember that you can always use either point as x1, y1 and the other as x2, y2, as long as you're consistent and don't choose one value to be x1 and the other one to be y2. That won't work out. Okay, so let's start here. If you want to label your points x1, y1, x2, y2. You can feel free, but you don't have to. Then you're going to just plug in to our slope formula. So I'm going to take my y2, I'm going to subtract my y1, I'm going to divide by my x2, subtracting x1. And then we're going to follow BEDMAS, so remember that there's implied brackets in the numerator and the denominator, so we're going to solve those first to get 4 over 6, and then we always reduce to our final answer to get 2/3 in this case. Since we have a positive slope like we saw up here, then we know that the graph will be increasing, and we can say that in our answer.
All right, with our next point, we could do the same thing. We could label our x1, y1, our x2, and our y2, and substitute into our formula. So we have our slope, which is represented by a lowercase m. Then we plug in our points. Our y2 is -6, and our y1 is 0, our x2 is 5, and our x1 is -3. When we go ahead and do this, we get a -6 over a +8, which reduces to a -3 over 4. Because we have the slope end up as a positive value,
Negative.
just kidding, a negative value, we can see that the slope will then be decreasing, or the function as a whole will be decreasing.
Oh, look, another example. Look at blue. I'm out of breath because I just ran up some stairs.
Mr. Thide's out of shape, you guys.
Let's get me some slope. Oh, that pen is thick. All right, I'm gonna sub things in. This is my x1. This is my x2. This is my y1, my y2. Do do do, do do do. Did you two say cool things while I was in the staircase? Or you just go ahead and do it?
We just did it.
Neat. So that slope's negative. Me thinks this is a decrease.
Okay, last example. So, label your points if you want. And then plug in and solve. By now, hopefully this seems easy and straightforward to you.
Didn't even change the font color.
I didn't. I'm not interesting like that, sorry. Okay, remember that when you have that double negative here and here, you want to always change that to adding, common mistake that I see all the time. So there's our reduced answer, and because it's positive, we have an increase.
Woo! All right, moving on. We also can have slopes of horizontal lines, and if we look at horizontal lines, let's go pink here, they have a slope of 0 because they don't actually increase and they don't actually decrease. So they neither increase or decrease. I.e. there's no change. Whoop, whoop. While the slope of a vertical line will be described as being undefined because it rises, but it doesn't run, right? And if our rise is some positive or negative value and our run is 0, that number over 0 doesn't actually exist. Therefore, it is undefined. So we are going to take a look and determine whether these points lie on a horizontal or vertical line, and we're going to provide the slope for each as we do. And again, we're going to change colors because that's fun. Ooh, will that be too light? We'll see. So we label our... Oh, that's a little too light. We label our points. We have x1, we have y1, we have x2, we have y2, when we calculate our slope. So we have our y2 minus our y1. And we have our x2 minus our x1. I don't know. I don't need that bracket for a positive value. And -4 minus -4 is the same as -4 plus 4, which gives me a 0. And we have 0 over -9. 0 over any number is just going to be 0. And just as the example or the note said at the top there, when we have a slope that is equal to 0, that gives us a horizontal line. Because there's no change.
Okay, so taking a look at the second example, I also want a new color. There we go, let's do purple. Okay, same thing. We're going to label our points. x1, y1, x2, y2. And then when we calculate this, same plug-in. So we're going to get 9 minus 16 over 9 minus 9. When we reduce that, -7 divided by 0. Now this should clue into your mind that we can't divide anything by 0 in math. And so then, because of that, we say that the slope is undefined. And again, referring back to the earlier notes, when we rise but don't run, then we have a vertical line.
So knowing that slope is rise over run can allow us to actually draw some lines with those slopes. For now, wherever we draw that slope isn't quite so relevant. We just need to pick a point to start and go from there. We will rise by whatever the numerator is and run by whatever the denominator is. So in this firstest case, where the slope's 1/2, let's make a starting point. I don't know, this one. That's a great starting point. In order to get to the next point, we will rise by 1, so okay, it's like somewhere up there, and run by 2, always going left to right whenever we run. So there's our next point, and if we play connect the dots, nice straight line.
Ooh.
That line has a slope of 1/2, and it's beautiful. Who else wants to do one?
Ooh, me! I love
Nerd.
math. All right, so if we take a peek at this next guy, and again, changing color, we want a slope of 3. And remember, if we have a slope of 3, 3 is really just 3 over 1. So in this case, we are rising by plus 3, positive 3, so we're going up, and then we're running over 1. And again, because there's no specified starting point, we could go anywhere we want. And today, honestly, feeling right here. And here we go, that's our starting point. And if we are going to rise 3, we are going up 3, whoop, 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 whoop. And if we are running 1, we're going to the right 1, bloop, bloop, bloop. And we are ending over there. And we are now just playing connect the dots and drawing this beautifully perfect straight line.
Okay, time for a negative slope. So if we take a look at this example, we have negative 5 over 7 as our slope. I'm going to pick green, my favorite color. Okay, really important. When you have a negative slope, that negative is going to apply to only one of the numerator or the denominator. I don't want to see any of this garbage because that is not the same because it reduces to a positive. Okay, so we're going to see either negative 5 over positive 7 or we're going to see 5 over negative 7. It will give you the same result. I always choose negative 5 over positive 7. That's usually considered mathematically more correct. Okay, so then again, same thing. Pick any starting point. Let's go with here. Oh boy, there we go. And then we're going to rise negative 5, so go down 5. And then run 7, so 7 across to the right. And that ends us up right over here. So then again, we're just going to draw that straight line. I did that wrong. I don't know how to use the iPad. It's fine. Just try this again.
Hold it.
Aha! Much better, Mrs. Friesen. Okay, there we go. And then just in case you wanted to count the other way, if you did choose negative 5 over negative 7 instead, then it does work the same. I'll just pick a different color to highlight this. Okay, you could have counted negative 7, so left 7, and then positive 5, so 5 up. And it would end you up with the same 2 points, which are meaning the same slope.
One final example is this final example. This deserves a completely new color. Yeah, there's a whole world of options.
Whoa.
This rise is huge. I mean, hugely negative, but huge nonetheless. Negative 8. So I probably don't want to start like here because I'm not going to be able to go down 8. That's rough. So I'll start maybe like, I don't know, here? That seems like a good spot. And I'll go down 8. I haven't been counting. I'll just assume that's good. And I'll run over 3. And I'll always play connected dots with this perfectly straight and slightly thicker line. Ka-cha. Check me out. Are there questions or comments or concerns? Classic. I guess there's some practice work. Do this.
Please.
You can find it in the textbook. So, should we stop recording there? Anything else we should say?
Check your Teams page for additional practice.
We should say that. Who wants to say it?
Oh, I just said it. I just did that.
Okay.
Oh, good.
Yay, math!